Example 5.2. A timber floor spanning 3.8 meter center to center is to be designed using timber joists at 400 mm spacing. The floor is subjected to domestic imposed load of 1.5 kN per meter square and carries a dead load including self-weight of 0.35 kN per meter square. Carry out design checks to show that a series of 45 mm times 190 mm strength group 4 sawn timber standard grade under dry condition is suitable or not. We start by gathering the geometrical properties of the timber joist. The effective span is 3.8, joist spacing 0.4 meter. Our B and H is 45 and 190. Therefore, our cross-section area is 8,550 millimeter square. Second moment of area, IXX, is 25.72 times 10 to the power of 6. So this is the timber joist that we want to check. We calculate load on the beam, given dead load and imposed load. Therefore, total load is 0.35 plus 1.5 times with spacing for the joist and effective length. We get 0.74 kN per meter. We list out all the modification factor required for the beam. For the duration of load, since this is the flow design, so the K1 is 1, K2 is load sharing applies because it has few timber joists, so the load sharing applies, K2 becomes 1.1. K3, we assume that less than 75 mm, so K3 is 1. No notch, K4 is 1. Rectangular cross section, K5 is 1. And the depth factor, K6 equal to 1. We refer to Table 4 Malaysian Standard Part 2 to obtain material properties of SG4 timber. We start by checking the bending for the timber. The formula for applied bending stress is M over ZXX. So M is the applied bending moment and Z is the section modulus. Our applied bending moment is 4.95 Newton per millimeter square. We calculate the permissible bending stress by multiplying bending parallel to grain times K1, K2, K5 and K6. We obtain 14.52. Our bending stress is satisfactory since our permissible bending stress is more than applied bending stress. Now we check shear capacity of our beam. For simply supported beam with UDL, the shear force we calculate as WL over 2. We get 1.41 kilonewton. Applied shear stress is 1.5 FB divided by A. So A is our B times H. We get applied shear stress of 0.25 Newton per millimeter square. For permissible shear stress, we multiply grade shear stress parallel to grain with K1, K2 and K4. We get 1.35 Newton per millimeter square. Our shear stress is satisfactory because our permissible shear stress more than applied shear stress. For bearing check, we take FV as 1.41 then we assume that our bearing width is 60 millimeter. We calculate our bearing stress by P over A. So A is the bearing area or contact surface. So 60 is the bearing width and 45 is the timber width. We get 0.52 Newton per millimeter square. Our permissible bearing stress is compression perpendicular to grain times with modification factor K1, K2 and K3. We get 1.815 Newton per millimeter square. Our bearing stress is satisfactory because our permissible bearing stress is more than applied bearing stress. We check our deflection for our beam. This is the formula deflection due to the bending. We get 7.1. And deflection due to the shear, we use this formula, we get 0.27 millimeter. Therefore, our total deflection is due to bending and due to the shear force is 7.37 millimeter. The permissible deflection is 0.03 LE and the answer is 11.4 millimeter. Since our permissible deflection more than total of our deflection, mean that our deflection is satisfactory. Lastly, we check for the lateral stability. We calculate our H over B for the timber beam is 4.22. So we use table 7 Malaysian Standard Part 2 to get the maximum HB. I screenshot part of table 7. This is our beam or joist. At both ends are held in position and top connected to sheeting. So we use the value of 5 as our maximum HB. Since our HB actual more than HB maximum given in the table, it means that our lateral stability is satisfactory.